Welcome back. This is part two of the videos that we'll be going through today in relation to parallel and perpendicular lines. Okay, perpendicular lines, they follow a lot of the same processes as what parallel lines do, except they just have a few different rules that we need to follow. Okay, so with perpendicular lines, they're very special in the sense that they meet at right angles, and that's what the word perpendicular actually means. Okay, it means to meet at right angles. Okay, so when we talk about right angles, we generally put the little box in, okay, to represent the 90-degree angle. Okay, so you can think in terms of lines, perhaps you might think about your floor running across your room, okay, and meeting the wall at the side of your room, okay? The wall and the floor are perpendicular to each other, okay? They meet at right angles. And you can see in our diagram here, okay, that I've drawn down, the same thing can happen with lines. They don't have to be straight up and down, horizontal across, okay? They may be diagonal and they can still meet at right angles, okay? Right, if you think back to our last video, parallel lines, they never met, okay? Now that was interesting when we thought about their gradients, okay? So let's have a little bit of a chat about the gradients of perpendicular lines, okay? So this is line 1 over here. We're going to say this has gradient M1, all right? M for gradient, okay? And this is our second line, line 2, all right? It has gradient M2. Now with perpendicular lines, okay, they have special rules about the gradients, okay? Instead of them equaling each other, if we multiply the gradients of perpendicular lines together, we get -1, okay? So if I multiply the gradients together, we get -1. This is a very important statement to remember, okay? We're going to be using that a lot today. Okay, now we can also manipulate this statement a little bit to get this one over here. Okay, now what you'll notice is all I've done is I've divided both sides by M1, okay, just to cancel it off to end up with M2 by itself and -1 over M1. We're also going to be using this statement here as well, right? And this is just saying the gradient of our second line of M2 is the negative reciprocal. Okay, now when I say the negative reciprocal, I just mean we flip our original gradient upside down and multiply by a negative. You're going to see this come in quite a few times throughout today when I teach you the faster process that you can use to find perpendicular gradients. Okay, all right. So let's start off with just checking our lines to see whether or not they're perpendicular. All right, we'll jump into a few questions that help us out with that. Okay, so here's our question. Are the following pairs of lines perpendicular? Okay, so is this line perpendicular to this second line here? So do they meet at right angles? Okay, so why don't we check? Remember the rule was that if we multiply gradients together if they're perpendicular, okay, our answer should come out to be -1. Okay, well if we look at the gradient of this first line, okay, it's -3. And if we look at the gradient of this second line, it's 1/3, okay? So if we multiply these two gradients together, for these to be perpendicular, we should end up with our answer being -1. So that means -3 times 1/3, all right? If we enter this calculator, or we can do this in our heads, we will find out the answer to be -1, okay? Right, so our answer to this question, are the following lines perpendicular? Well, for these first two, they are. Okay, they are indeed perpendicular because if we multiply their gradients, we end up with -1. Now let's have a look at our second pair of equations, right? We have y equals 2x plus 1 and y equals 1/2 x plus 3. Okay, the gradient in our first equation is 2 and the gradient in our second equation is 1/2. So we should multiply these together, and if we get -1, we know the lines are perpendicular. That means they meet at right angles, okay? Right, so we do 2 times 1/2. Again, when you're doing this step, you can enter this in on your calculator if you're not confident, okay? But I encourage you to try and do it in your head, okay? 2 times 1/2, well, that will end up giving us an answer of 1. +1, not -1, okay? So while, yes, these lines are perpendicular, these two lines here are not. We need to have -1, okay? You'll notice if we go back to our original example that the gradients, right, for our lines are different, okay? The first gradient is positive and the second gradient was negative, okay? Which means one of our numbers, whenever we're doing this, needs to be negative and it needs to be the reciprocal of the other, okay? Right, now reciprocal just means we flip it upside down, okay? So why don't we have a bit of a practice with actually finding the equations of lines that go through certain points and that are perpendicular to other lines. Okay, so this question here is asking us to find the equation, so we're going to find a new line, just like what we did in the last video, right? Of a line that passes through the point 0, 2, okay, so we have a coordinate, and is perpendicular, okay, so that's going to be important to us, okay, to another line with gradient 3. Okay, so it tells us what the gradient is. It gives us 3 key pieces of information, okay? Okay, so when we're finding the equations of new lines, it's very similar to what we did with parallel lines, okay? So the first thing that we had to find was our new gradient. Now remember, at the start of the video, we had a little bit of a chat about this formula. M2 is equal to negative 1 over the gradient of our original line. This M1 is the gradient of our original line, okay? The reason why this formula comes into play is because it is perpendicular. If this was parallel, we would just make the gradients equal. But because we're told that it's perpendicular, we have to use this formula, okay? Right, I'm going to show you a shorter way in just a moment that I can help you calculate this out. All right, so let's jump into calculating the gradient first off. Now, it must be perpendicular to a line with gradient 3, all right? So in this particular example, all right, our gradient, our M1, is 3. So to calculate a gradient of our perpendicular line, all right, our new one is M2 is equal to minus 1 over our original gradient, which is 3, okay? And we don't have to do anything else with that, right? So our new gradient is going to be minus 1/3. Now, we found the gradient. Remember, I kept saying that our new line is going to be in the gradient intercept form. So y equals mx plus c. We found the gradient. Now we need to find the y-intercept. So let's use another piece of information that we have in our question that we're given. And it's this point here. I want you to think about this point and just visualize it for a moment. Okay, just like before, is that point lying on the y-axis? Well, at 0 and 2, okay, we start at 0 and we go up to 2. All right, so that is on the y-axis, which is fantastic for us because it cuts out a lot of the work, okay? It means that we can find the y-intercept immediately because that's the point on the line that we're talking about, okay? We're talking about this point on the y-axis. So the y-intercept, this c value, right, the number that floats off by itself, is equal to 2, okay? So we have c equals 2. So if I end up with the gradient and I end up with the y-intercept, I can just plug everything into my gradient intercept form to generate my new line. Okay, so my new line will look something like this. Y equals negative 1 over 3 x plus 2. Okay, I've just replaced my m with the negative 1 over 3. Okay, and I've replaced my c with the plus 2. This line is perpendicular to whatever line has gradient 3, okay, so it meets it at a right angle, all right, and it goes through 0, 2, the point 0, 2, which is the y-axis intercept, okay? So that is all you have to do if you're given a point that lies on the y-intercept, okay? So why don't we have a go at a little bit of a harder one, okay? So here's our next question, very similar to the last one that we've just done, okay? What is the equation of a line that passes through the point 0, minus 1 and is perpendicular, right, to a line with the gradient 2, 3. Okay, so very important pieces of information that we've just been given. We have to find the equation that goes through the point 0 and minus 1, is perpendicular to a line, our original line, that has a gradient of 2, 3. So first things first, we need to find the gradient of our new line that's perpendicular. So we're going to use this formula. Right, M2 is equal to minus 1 over M1, where M1's our original gradient, which we're given 2 here, aren't we? Okay, so all I'm going to do to calculate my new gradient is I'm going to replace this M1 with 2 over 3. So negative 1 is equal to 2 over 3. Now earlier on in the year we taught you about dividing by a fraction and how we can't do it. Okay, so what we have to do, we can't divide by a fraction. Okay, so we have to cross it out and multiply by the reciprocal. Okay, right? Now, the reciprocal is just the bottom fraction flipped over on top of itself, okay? So our gradient will look something like this, -1 times 3 over 2, all right? Now, 1 times anything is itself, okay? Right, and a negative times a positive is a negative. So our new gradient is -3 over 2, okay? Now we're going to come back to that. I'm going to show you a much faster way of being able to calculate that. All right, you may have already figured out the pattern already just by watching me do that. So we've found the gradient, okay? The other thing that we need to find is the y-intercept, because remember, we're going to put it in the form y equals mx plus c, okay? So we have the gradient, now we need the y-intercept. So the first thing that you should do is look at your point and ask yourself, does it lie on the y-axis? If your answer is yes, you're in luck, okay? You've cut yourself out a lot of work, okay? And the point 0, 1, well, that does lie on the y-axis. So it's here at x equals 0 and down here at y equals -1, okay? So that means that our gradient intercept form is really easy to calculate. Our intercept is just c equals -1, okay? Because that's where it crosses the y-axis. So we just take our c and our m, right, our intercept and our gradient, and we plug it back into the original equation. And this is what we get. Y equals -3 over 2x, right, because we're replacing the m now with our gradient, okay, -1. Okay, so this is our perpendicular line to our original line that had a gradient of 2/3, right? So it meets whatever line this is, right, at a right angle. Now let's just stop and just have a think about this, all right, and what it actually means, and how we're actually able to make this process here a little bit faster. Okay, let's just go back to our original question. You'll notice that the original gradient that we are given is 3, and I want to find a perpendicular gradient. You will notice that I end up with a fraction, okay, of being -1 over 3. So to find our perpendicular gradient, all we do is we take our original, right, our original gradient, 3, and we flip it, and we multiply by a negative. Now, when I'm flipping just a whole number, it might help if I write this over 1, okay? So all I'm going to do, all this process does, is flips and multiplies by a negative, okay? So we're going to flip 1/3, all right? Flip 3 over 1 to become 1/3, and we're going to multiply by a negative, and that is our new gradient. Okay, so we cut out all of the work here and recognize the pattern that's happening. So the same thing is for this one, okay? Our gradient given to us was 2/3. So let's go down here and write this out. 2/3, okay? We want the perpendicular gradient, so we flip and multiply by a negative. Okay, so we flip it, 3 over 2, and multiply by a negative. Okay, and that will give us our perpendicular gradient. All right, so my question to you is, we've just went and found equations of lines that have the y-axis intercepts given to us, but what happens when the y-axis intercepts aren't actually on the graph and we're given a different point? We're going to have a look at that right now. Okay, so what happens if our point isn't on the y-axis? In both of our previous examples, both of our points were on the y-axis, right? Our vertical line going up and down on our Cartesian plane. All right. Now that process was exactly the same as parallel lines, and this process here, okay, will be the exact same. Okay. The only modification that we do, all right, in relation to parallel lines is we just use a different process for calculating the gradient. Okay. So let's have a look. We want to find the equation of a line that is perpendicular. It's really important that we understand that we're finding the perpendicular line, right, to this original line here, y equals 1 over 4x minus 1, and it passes through the point 3 and minus 2. So what we want to do, okay, is we want to find the gradient first off, okay, of our new line. Now we know the gradient of our original line. I'm going to write the gradient of our original line right here, okay, m1 equals 1 over 4, okay, it's whatever number is attached to the x. We want to find the gradient of our new line, and we know that it's perpendicular, okay? So we use our shortcut that we just had a little bit of a chat about. Our new gradient will be, okay, whatever our original gradient is flipped, so 4 over 1 and multiply by a negative. So we flip the gradient and multiply by a negative. That's our shortcut. Okay? So negative 4 over 1, well, we can actually simplify that. Okay? That's just negative 4. 4 divided by 1 is 4 still. Okay? So we found our gradient, okay, for our perpendicular line. Remember, it's going to meet here at right angles. Okay? Our perpendicular line, if we put it in y equals mx plus c, remember we always come back to this formula, will look something like this. Y equals, instead of an m, we're going to put a minus 4, so a minus 4x plus c. Alright? Now, we have one thing that we have left to find. Okay? The y-intercept. We have this plus c that we have to deal with. We have the gradient. Our second step is to find the y-intercept. And you'll remember from our parallel lines video, okay, that we can use our point here to help us out. Okay? So remember, this was an x value and this was a y value. Okay? So our x is equal to 3 and our y is equal to minus 2. And this is now the exact same process as what we did in the parallel lines video. So now what I do is I replace my x and y values in this equation. Okay, so I sub them in, okay, to find my y-intercept. So first step gradient, second step y-intercept. Let's do it now. Okay, instead of a y, I'm going to have a minus 2. So I sub in a minus 2 wherever I see a y. Okay, and I put brackets around to let myself know that I've subbed it in. Minus 4 times, and again I'm going to use brackets, times, instead of an x, I'm going to put a 3. Alright, 3 plus c, because we still don't know what that y-intercept is, because our point is not on our y-axis. Okay, let's tidy this up a little bit. I have minus 2 is equal to minus 4 times 3 is minus 12 plus c. Okay, and now I want to get c by itself, so to do that I need to get rid of the 12. So I'm going to add 12 to both sides. Okay, that will cancel, and that will leave me with c is equal to 10. So I've just found my y-intercept. So using this equation here that we found, right, because we only wanted to find what our plus c is, we can plug all of our values in, our gradient and our y-intercept, okay, to generate our perpendicular line. So we end up with y equals minus 4x. Instead of plus c, it's now a plus 10, because that's what we just went and found. Okay, this is our new line, our perpendicular line. Okay, perpendicular, okay, compared to our original line up here. Okay, so this line here and this line here meet at right angles. Okay, that's what we mean by perpendicular. Let's do one more example. If you're feeling confident, you're welcome to move on. Alright, I just want to do one more example just to make your learning concrete. Okay, so here's our last question. Find the equation, okay, of a line that is perpendicular to this line here, alright, and goes through the point 1, 3. Okay, so it's perpendicular to y equals minus 2 plus 5, minus 2x plus 5, and goes through the point 1, 3. Okay, I keep going back to our parallel lines video because that is exactly what we're doing, the exact same process. Okay, we're finding the gradient, we're substituting in a point, and then we're writing our equation. That's all we're doing. Okay, now the only thing that's different is how we find the gradient. Okay, and because it's perpendicular, we flip and multiply by a negative. They're just not equal to each other. Okay, so if we look at our original line, we can identify the gradient of the original line and use that to help us to find the new one. So our original line's gradient is m1 equals minus 2. Okay, now this might help you to understand how this is going to work in just a moment. I'm going to put this minus 2 over 1. Now I haven't changed my number there. Alright, now if my new line is perpendicular, to calculate my new gradient, I have m2. Alright, what I do is I take my original gradient, I flip it and multiply by a negative. Right, so I flip this so it becomes 1 over 2 and multiply by a negative. Right, now let me just put this negative here. One of the things that we need to remember, okay, is that this value here was already negative, okay? All right, so I'm going to put that negative in a bracket, all right? Now, this negative here is what we'll be multiplying. Now, just remember, when I multiply a negative by a negative, my answer will be positive, okay? So my new gradient for my perpendicular line is 1/2, That means if we use our gradient intercept form, okay, I keep writing out the equation to help us out. Okay, if I use my gradient intercept form, I know what my gradient is. My line will look something like this. Instead of an m, I have a half x plus c. So our first step's done. Now we need to do our second step, okay? Which means we need to find this y-intercept and then we're done, okay? So to do that, what we need to do is we need to use the x and the y value from our coordinate. We sub in our point, okay? So we know that x equals 1 and y equals 3. So instead of having a y and an x to find c, we're going to replace them with numbers, okay? So we only have one thing to find, okay? So here's what we're going to do. Instead of a y, I'm going to put a 3. Instead of an x, I'm going to put I'll make sure that I put brackets around. I'm going to put a 1, okay? Now we tidy this up. This just becomes 3 is equal to a half times 1, right? So that's just a half plus c. Now the next thing that we're going to do, okay, is we're going to subtract off a half from both sides because we want to get the c by itself. So I'm going to minus 1/2. Now you can do this step on your calculators if you want. You can do it in your head. This is like me saying 3 minus 0.5. So you will end up, if you do this on the calculator, with a decimal looking like 2.5 equals c. Okay, but what I want you to do is I want you to make sure that you write that as a fraction. Okay. Now, if you've done it the decimal way and you've entered in on your calculator, if we put in 2.5, you can press this little SD button, okay, to convert it to a fraction, okay? All right, so we have our answer as a fraction. It's c equals 5/2. That is our y-intercept, okay? So we've found our gradient, okay? We found our y-intercept. Let's rewrite our equation. Okay, our perpendicular line to be y equals 1/2 x plus 5/2. Okay, that's how we find a perpendicular line. Okay, this is our new line. This is the line that we started off with, and the lines meet at right angles. Okay, I hope this has helped. Okay, please use this to answer any questions that you might have, and have fun. Bye.